Okay, well, paper 2 is finished, and for those who are watching this right, done that. Congratulations, you finished everything for GCSE Maths. If you're level onwards, you've done all the maths you need in your life so far, basically, formally speaking. So well done for that. For those that doesn't apply to that, or like if you're watching in the future or just watching now and you're curious about some of the questions in the 2022 summer papers. Um, I do offer tutoring, and there's a link in the description. Says link in bio here, but really I meant link in description. And for those who are watching and you want some questions covered, and again, I accept all questions from all exams, and actually today I actually do have one AQA question to change things up. But yeah, feel free to submit some questions in the comments. They're still welcome. Okay. With that said, let's crack on with some of these questions. Okay, so the first question I've heard from quite a few students that they struggled with was from Edexcel. It's to do with probability. So the question has someone called Ray, or maybe not, but the names aren't important, the numbers are. Ray has 9 numbered cards, numbered from 1 to 9. He takes 3 at random and he adds the values together to get a score. What is the probability of the result being even? Okay, so what are a few things we need to establish first? Okay, the question implies, from what I've been told, that is the cards aren't replaced because you're taking 3 cards and you're adding them afterwards, so they're independent. So they are not independent; they are dependent on each other. So every time you take a card, that will change the total number of cards there are. And the other thing is, let's just quickly establish the number of odds and evens. Okay, so from 1 to 9, there are 5 odds and 4 evens. Okay, so therefore, the probability for getting an odd to start is 5 out of 9, and for even is 4 out of 9. Okay, but because the events are dependent, that every time you take a card, as well as changing the top, uh, depending on whether you're looking at odd or even again, but the bottom definitely changes. If you take 1 card, the bottom goes to 8, and likewise 7 and onwards. Okay, so with that said, let's just establish, instead of just counting out like ones and twos and threes, like we can just separate the 1 to 9 into odds and evens in terms of the scores, because the rules will stay the same. Okay, so just so we only have 4 combinations now instead of uh, 9 times 8 times 7, whatever that may be. Okay, so the 4 combinations we can have, or 4 types of combinations, are odd, 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 even, 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 and 2 odds and 1 even, and 2 evens and 1 odd. Now, odd, odd, odd gets us an odd number. Okay, even, even, even gets us an even number. Okay, so in terms of this even, even, even is good. It applies to our probability for the answer. Okay, odd, odd, even also gets us an even number. Okay, if you want more explanation of this, I can talk through it in the comments. And even, even, odd gets us to odd. Okay, so we just need to find the probabilities of these two. Okay. Okay, with that groundwork out of the way, let's actually think of the scenarios that work. Okay, so uh, even, 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 there's only one. So there's one scenario that will work. Now, we need 2 odds and 1 even. Okay, so the amount of the different scenarios for that, as laid out, so it's just two O's and 1 E is a O E E, E O O, and O E O. Okay, so these are the 4 probabilities, and we just need to find them all individually and add them together. Okay, because the only prerequisite knowledge we need to know here is uh, the probability of 2 scenarios, and like scenario A and scenario B is timesing them, and then so here will be E and E and E, for example, O and E and E. So you times the individual E's, evens, and the probability for all is plus. So you would add within these scenarios you multiply them, and once you have each individual scenario, you just add them, okay? Okay, so let's find these individual probabilities. And remember, these are starting probabilities, so they're going to need to change, okay? Uh, okay, let's go with evens, 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 okay? So at the start, there are 5 evens out of 9 total. And then remember, and is times, okay? So now we've lost one even and we've lost one, we lost one from the total. So now it's 4 out of 8, okay? Because 5 minus 1 is 4, 9 minus 1 is 8. I know this simplifies to a half, but for simplicity's sake, I'm just going to keep it as is and do the same a third time round. So you get 3 times 7. And this is a calculated paper, so it really doesn't. So I'll just be straightforward with this. So the probability of EEE by itself is 1 out of 21. Okay, so probability of EOO, so even, odd, odd, and the same thing again. Okay, so we're starting with an even. So it's 4 out of 9 as a start. Now, how many odds are there now? Okay, so we haven't lost any odds, so it's still 5 odds, but we lost one from the total. So it's 5 times 8. Sorry, 5 over 8. And then, and again, so another odd. Okay, so how many odds are there? We lost one because we drew it a second time, so there's 4, 5 minus 1, and the denominators keep on staying the same. They're always 9, 8, 7 because it's going down by 1 each time. And the answer to this is 10 over 63. Again, excuse the handwriting, that is 10 over 63. Now, for those of you who aren't as like certain about your maths or not as confident, the answers for OEO and OOE are gonna be the same. And do excuse the handwriting. OEO and OOE are just gonna be the same, but I'll just do OEO first to show the case, and then we'll continue on from there. Okay, so OEO. We're starting at, so an odd first, so 5 out of 9, okay, times, okay, even, so what are we starting? So the bottoms are always, before we get to that, the denominator is always 9, 8, and 7, because it's going down each time. Okay, so even, there are 4 to begin with, so 4 out of 8, and then now, going back to odd, it's going to be, okay, so we had 5, now we're going down 1 to 4, okay? So OEO is also 5, 4, 4, and likewise, it'll give us the same. Okay, so 10 out of 63. And so, yeah, so the denominators stay the same, but numerators, they just change in order, but there's always 5, 4, 4, okay? We'll just be safe and go through the same with OOE again. So first odd, 5 out of 9, lose an odd, so now it's 4 out of 8, and then it's 4 evens to begin with, so 4, 7, so 10 over 63. Now we add this together, and I said this is a calculated paper. The answer is just, well, the calculator will just give you straight up 11 over 21, but you can add it all, these three, and then add that if you want to. So 30 over 63 plus 1 over 21, which equals 11 over 21. And that there is your answer, ladies and gentlemen. Hopefully you got how we got there, and yeah. Okay, there's other questions also from Edexcel's paper 3, and quite a few struggled with this. Now, this question has a lot of different parts that can be broken down, and the individual parts are actually hopefully pretty straightforward otherwise, but combining them makes it difficult. Okay, and the only prerequisite knowledge you need to know is the area of a trapezium, the formula for that, basic Pythagoras, and basic trigonometry. Okay, so let's break it down to start with. So let's look at this plane. Oh, and also one important bit of information. We are told that the trapezium area is 147 centimeters squared. Okay, sorry, that's a given in the question. Okay, so yeah, so let's look at this height. Okay, so that's an unknown. Part of quite a few different unknowns, but let's see if we can break it down. Okay, so Okay, so we got this unknown. Let's just call it SD. So SD here, and we got 14 here and 12 here, and the area is 147. So with this, we can actually find SD. All right. So SD. So the area is 147, and the formula for an area of a trapezium is the average of the two parallel sides divided. So that plus that divided by 2 times its perpendicular side, the non-parallel one, or perpendicular height if it's a triangle of 2 slanted sides. Okay, so here the answer. So to get 147, it'll be SD plus 12 divided by 2 times 14. Okay, so again, this is a calculator paper, so we can make this pretty simple. We'll just move some stuff around. So times 2 divided by 14, we can do that 147, which gets us to 21, equals SD plus 12. So therefore SD just equals 9 centimeters, okay? So now we have 9 here. Okay, so the first step we did was to find this height here. And now the second step, we have this unknown and this so TC and DT, okay? And these both steps kind of both merge into one larger step, these smaller steps. So I'm addressing them together here. Okay, so I've drawn, and apologies for the bad drawing, but I'm not a great artist. I'm an okay mathematician, and I would say I'm a great maths teacher. But yeah, drawing's definitely not one of my skills, and yeah, so if it's not clear, I've drawn a dotted line between D and T. It's along the base, and these three form a right angle triangle here because this is on a corner of a square. So yeah, we've got this side which is 14, and we got these two other mystery sides. Okay, so so the first thing to do is to find CT. Okay, so whole thing of B to C is 14. Okay, but we have been told there's a T, there's a point in between BC, and the ratio of this length, BT, to TC is 4 to 3. That's a given from the question. So this is in itself also kind of a ratio question, but just a really quick short and you're done with ratio part of the question. Okay, so 14 is the whole, so 4 plus 3 is 7, like the sort of total number of parts. So 14 divided by 7 is 2, so 2 is one part. So then the ratio of the lengths BT to TC must be 4 times 2, which is 8. So this is 8, and 2 times 3, which is 6. Okay, so now we have these distances, okay? Now we also have it here. All right, so that's that done, okay? So now with just basic Pythagoras, we're gonna need to find dt, okay? So dt squared is 14 squared plus 6 squared. So dt, again, is just root of 14 squared plus 6 squared. And therefore, with the help of a calculator, dt is 2 root 58, okay? So here we have 2 root 58. So this is 2 root 58, all right. Okay, so with all the steps done, we got a final step now. Okay, so so we have this distance, dt, we have tc's distance. Well, we no longer need that, but remember our first step was to find distance from either A to here, or it's the same distance here, but it's easier to draw that, S to D, which is 9, okay? So let's imagine triangle SDT, okay? It's a right angle triangle. Now, the base is long here and the height is long here, so we're looking kind of this way at it. Okay, so that looks like 5, SDT. This is 9, and we just figured out this is 2 root 58. Now, the question is to find this angle. Okay, so now this is a right angle triangle. We have, from the perspective of this angle, we have the opposite, and we have the adjacent. Okay, so that's all that we need. Okay, so as you can see, broken down into little steps, this is a pretty simple question, but all aggregated together it might get a bit tricky. So we know our basic SOHCAHTOA. Sorry, again, poor handwriting. So yeah, this is the one we're interested in, okay, because it's got opposite and adjacent. So tan SDT equals opposite over adjacent, which is 9 over 2 root 58. So SDT must just equals to tan minus 1. This is shorthand for ditto, so it's just that. Okay, 9 over 2 root 58. And the answer is, again, with the help of a calculator, is 30.5779, whatever. I believe, from what I've been told, it was 1 decimal point, was what one of the students told me. So here you go. Right here is the answer. So yeah, hopefully you got that. But yeah, and if you're not watching right after the exam, hopefully this makes it clearer as to how you break down complex geometry questions like this. Step by step, it's pretty simple, and I know you can all do this, okay? Okay, so here we got another Edexcel question to do with circle theorems from paper 3. So this one's actually pretty straightforward, but it's unfortunate, you kind of know it or you don't, but you can also get part of the marks, okay, hopefully. So yeah, we have a circle here, again, very poorly drawn, and 2 triangles here. They're both these points, or all 4 of these points are touching the circumference. And yeah, okay, so these are both straight lines. Okay, so the only prerequisite knowledge, is circle theorem. Circle theorems, and you only need to know one of them, which is angles from the same segment are equal, and how to prove similar shapes with angle, angle, angle. Okay, so I'll try and use try and use all the colors I have, my colored pens to show you this. Okay, so the first one is pretty simple, where you can get, most of you will probably get at least these marks, is vertically opposite angles are identical, okay? So these 2 are the same, so blue and blue are the same. Okay, so in black, I'll try and draw 2 chords, again, as both these points are touching the circumference of a circle. So this, in a dotted line, is a chord, and likewise here. Now, looking from the perspective of this segment, just think about it like kind of this shape, ignore everything else. These 2 angles must be equal because they're both they're both angles stemming from the same, coming from the same chord in the same segment. And likewise, these 2 are equal. Okay, so yeah, this question, once you know, it doesn't take a lot of time, but hopefully that makes it clearer how you can spot these in the future. So the general takeaway for this, for circle theorem questions and in general geometry questions, just put as much information you can on a piece of paper. Okay, so recognizing there's a chord here and there's a chord here, there you go. Once I put those dotted lines in, hopefully those of you who didn't get initially would get immediately. That's definitely the reaction I had with one of my students. Okay, and this is the final Edexcel question I have, and after this I do have one bonus AQA question. Woohoo for all those AQA viewers. Okay, again, my student didn't remember the names inside the question, but that's fine, I'll just replace them with A, B, and C. All the maths and all the numbers that my student remembered should be correct, okay? So, yeah, so A has X counters, B has twice as many counters as A, C has 6 less counters than B, the total number of counters was 54, and find the ratio in the form of 1 to n of A to C counters. Okay, so this is just not basic, not straightforward, but a somewhat complicated ratio question. Okay, so it already tells us that A has X counters, I believe. So tricky part with ratio questions that a lot of people find an underrated part, and maybe I should do a video on this, not just for ratio, but for probabilities, is for expressing things in 1 or 2 just limited amount of variables. So now we've been told that A has X counters, and that is the one variable we have to start with. Now, can we express everything we have in terms of x? So b has twice as many counters as a. So actually, let's just underline what we need. So a has x, so b has twice as many a. So b actually has 2x, okay? Now, c has 6 less counters than b. So it's just b minus 6. But instead of saying b minus 6, we can just write 2x minus 6, okay? So the total is 54. And we've broken down a, b, and c, the only parts that make up 54. Only bits that make up 54. Their counters, I mean. So we actually have everything we need to find x, which is a's counters, okay? So let's just write it all out. Okay, so x, a, just labeling it. You don't need to do this in the exam, just to make it clear for you, the viewer, plus b's, 2x, also spacing that on purpose, plus c's, 2x minus 6 equals 54. Now, with a bit of a rearranging, so let's add all, so there's x plus 2x plus 2x, so that's 5x, minus 6 equals 54. And a bit more rearranging, 5x equals, so to get rid of the 6, we add it on both sides. Get rid of minus 6, I mean. So, just 5x by itself, and 54 plus 6 is 60. So therefore, x is 12, because 5x is 60, so divide both sides by 12. So there we go. We have a's, okay? So actually, 12 counters. Now, to get c's counters, we can find b's, but that's not relevant to the information. Okay, so c's counters, okay? We just sub in x. So 2 times 12 minus 6. 2x minus 6, 2x minus 6, which is a calculator question, so just get it instantly, it's 18, all right? So 18 counters. So the penultimate step, the ratio from A to C, is therefore 12 to 18. Now, we just need to inform 1 to something, okay? So what's 18 divided by 12? Put in a calculator, that's your answer, okay? 1 to 1.5. Okay, for those of you who made it this far, we got a little bonus AQA question for you. So it's to do with prime factors, HCF, and LCM, highest common factor and lowest common multiples. I'll just be saying that and writing that to just kind of save time and save effort, okay? So one thing I gotta just clarify before this, the submissions I got weren't fully sure on the questions themselves, but talking to multiple other AQA students were pretty certain on the answers. But as we explain and go through, it'll be clear as to why we're not 100% certain on the questions. But yeah, but likewise, so we've been given two numbers. They're actually called Q and R in the paper, but again, like we won't show which one's Q, which one was R. And they're broken down into prime factors already of 2, 3, and the third prime factor of A, all to different powers, and the highest common factor of 4056. So part A is to find A, so let's address that. Okay, so let's just plug in all the information we have. So the highest common factor, if you find anything between two numbers broken down to prime factors, is you would take each prime factor by prime factor. So let's look at the 2's, and you'd find either the lowest. There's two ways to visualize this. Just look at the prime factors and look at the lowest one across them. So the 2's exist for both. Okay, so we're gonna have 2 to something, and the lowest one is 2 to the 3, which is lower than 2 to the 4. Another way to look at it is just like it's the same thing, but visualizing it a bit differently. It's just the biggest chunk that will go into both. So 2 to 3 will go into 2 to the 3 and 2 to the 4. Awesome. 2 to 2 can go into both, but it can go bigger. 2 to 4 won't go into both. Okay. And with the same logic with the 3's, both have 3's, but the smaller one out of the 2 is just 3 to the 1. And then, okay, with the A's, same logic, A squared equals 4056, because we've been told that's a given, okay? So we can use a bit of simple algebra and get us to 4056 divided by 2 cubed times 3, which this is 24, but doesn't matter. It's a calculator paper, so we've got the answer. We can get the answer pretty immediately, and the answer is 169. Now, some of you may be able to instantly recognize that as a square number, but doesn't matter. It's a calculator paper, so root that, and you get a equals 13. Okay, so that is pretty straightforward. That's how you do the first part, part A. Now part B, with lowest common multiple. Okay, uh, so yeah, how you would do that is you would look at prime factor by prime factor again. So the question's already broken that down for us. Now we know A is 13. And instead of going the smaller one, you would pick the bigger one out of two. And I'll highlight an example where you can make a rookie mistake, okay? Because you're combining things, you're visualizing like that. So let's look at twos, for example, okay? So the rookie mistake would be 2 to the 7 because, okay, so them combined, so it's 3 and 4 together, so 2 to the 7. But no, you just pick the largest one that across both because 2 to 3 is part of 2 to the 4, okay? Again, you repeat. So, okay, so across the threes, which one is the biggest? Oh, firstly, they both have a 3, okay? So we're going to have a 3 here, and then which is the biggest? Okay, 3 squared. And likewise, A is now 13, and which is the bigger one? 13 cubed. And now, yeah, this is a calculator paper, so that's all you need to find B. And the answer is in the realm of 300,000, so it's 316,368. And that is your answer for part B. And we have checked these answers with multiple AQA students. And yeah, and this is what you should have gotten. So just be clear about like not remembering the question fully. It's just maybe like, so across the two prime factors, bunch of prime factors of Q and R, maybe like some of the prime factors just mix. So this could have been 2 cubed times 3 squared times A cubed, like, but we just know across both of them there's a 2 cubed and a 2 to 4, there's a 3 and a 3 squared and an A squared and an A cubed. So what order they come in, or which is in which, that may be where where it's questionable, but otherwise the rest of this is sound and the questions and the methodology are completely sound. Okay, hopefully all of you guys did all right, and hope you enjoyed this as well. And for those who were just watching who didn't just come out of this exam, hopefully this was helpful in you learning a bit more, making some things a bit clearer. And if you enjoyed this, please do give a like, do subscribe. I will try and come up with more content in the future. And if there's any additional questions from the exams that you guys struggled with, please do let me know, and please do give some detail because every little bit helps. And and finally, just to plug again, I am a private tutor by trade. If you want some proper one-on-one work, my link is in the description.